Let's move on application of tempering. Basically, the tempering is widely used for in glass industry, and this glass has been used widely for all part of country. So whereas application of tempering is it's architectural glass, either in the form of you can use a monolithic glass, or you can use a double glazed, or it will be laminated. But the tempered glasses is widely used because of the safety nature and impact resistance and blow resistance, like outside wind resistance and distortion has to be tempering glasses would be there, but even that can be eliminated, it will be reduced with help of a good tempering process if you have a continuous process, continuous chambers are there. So these are the applications of architectural glass, of tempered glass. And you see the complete clear glass building. These are the tempered glasses. And lobbies, inside the lobbies, not only the exterior facade, there is no restriction at all. It can be used for the interior application partitions as well. Interior, so what are the glasses you saw that inside the building, which is completely tempered, the glass, tempered. And most important, next is automotive sector. Yes, widely used for windshield and side windows, backside windows. Those automotive sectors have been used laminated glasses, which tempered glasses. Safety aspect of this is one of kind in tempering process and laminate process. People are widely used in glass in automotive sector. So let's move on. Heat strengthening. So what is meant by heat strengthening? Heat strengthening is a process. It's nothing but the rate of cooling is differs. The similar as good as tempering. The heating is similar. The rate of changes in the process called a cooling and quenching process. How slow you are cooling the glasses, you will be getting the heat strengthened glasses. So what is heat strengthened glasses? We discussed about right now. So it is a glass which has been heat treated in order to increase the mechanical strength and resistance to the thermal breakages. Again, as good as similar tempered glass definition, but the heat strengthening process is similar to the process of toughening process, except that cooling is done at the much slower pace. So that's having said that. So how fast you are cooling the glass, you will be getting the tempered glass. How slow you are cooling the glasses, you will be getting the tempered glass. So then you will be getting a heat strengthened glasses. This is the process increase the resistance of the glass to mechanical and thermal stress up to 130 degrees centigrade. Whereas tempered glasses, it can resist up to 200 degrees centigrade. The fragmentation of the heat strengthened glasses are similar to that of ordinary annealed glass fragmentations. But heat strengthened glasses is twice as stronger than the annealed glass. So heats in the glasses, you can see that up to 100 or 120 and 130 degrees centigrade, that the thermal shock proof can be resist up to 130 degrees centigrade. Whereas annealed glass, you can see that the rightmost, which is 50 degrees centigrade, the fragmentation is completely differs. So this is the fragmentation pattern. If the glass breaks, kind of breakage pattern, you can understand either it is annealed glass or it's tempered glass or it's a heat strengthened glasses. So this is the difference between heat strengthened glasses fragmentation and tempered glass fragmentation. Let's move on. Low-E glass tempering. So low-E glass has following characteristics. It has a low emissivity coating in nanometers, low emissivity. And it has a range of between 0.04 to 0.40. It has resistance for far infrared radiations. It is used for heat control and radiation control and thermal insulation glass. There are two types of low-E glass and online, that is called the CVD, chemical vapor deposition, and one is called offline, which is called physical vapor depositions. So this is the funness. You are fed as a low-E glass inside. Basically, the Lowy, which is coating, is on the air side, which is not touching on the roller side. That is called air side. So Lowy glass fed as on the air side. So what is happening? So when it's as soon as the glass gets inside, within 60 seconds, the glass would tends to bend like convex. So because why this is? Because the Lowy coating, it reflects the heat more, because it's a Lowy, it's emissivity, low emissivity coating. It reflects more heat on the top. So due to that, so the glass after 60 seconds, immediately glass will go like a concave, like it's a dish, like a boat kind of this. In order to avoid such a defect, or if you want to make it as a flat, so what you have to do, we have to increase the top temperature a bit, and you can play the air pressure on the top. So thereby you can make it a flat in terms of Lowy glass processing. You see that the more heat comes in the top and more air comes in top, so thereby you'll be attaining the flatness of the glass when compared to the Lowy glass processing. And combination of convection system, which is it's a preheated, which is Lowy glass has been heated up in the one chamber. After that, and immediately pass on to the another chamber, which is combination of convection, which is basically two types of batch process will be taken place. That way, you'll have a more optical quality, because Lowy tempered glass has a more distortion at the when you glaze it outside. In order to avoid that, if you use as a continuous process, like a combination of convection system, whereas it is not on the single chamber alone. If you have a continuous chamber, you'll have a greater optical quality. You can get it out of this without changing the characteristics of light transmission, shading coefficient, everything. And Lowy glass, if you see that the glass breaks, not only the Lowy glass, or any glass, if it is in the furnace, if it is not as a good recipe, the glass would break like this, start like this. Let's discuss about on defects in tempered glass and common defects, or what are the common defects or there in the defects in tempered glass. Breakages. This is happening in the chiller, or this is happening in the furnaces. There are two types can be done also. Let's see what is the issues, what is the solution. The reason for the crack. Glass has a crack. Manufacture the flowed glass without crack. So which means what the solution, if you fed in the glass recipe, with fed the glass inside the furnace, you should not have any crack as a unyieldy glass form. Thermal shock is large. For example, thermal shock, people are, when you glaze it outside, the glasses started breaking its own, like self-suicide kind of this. So avoid loading the glass at very low temperature. Okay, so should be as good as 680 for 6 mm, 680, 700, within the range you have to fed. If it is less than the limit what's specified, the glass would break in the furnace. And furnace temperature is high while loading the thick glasses. So imagine we have discussed about this main parameters for the heat tempering. So thickness as goes, the temperature is less, whereas your heating time will be increases. So furnace temperature is when is high, well, at the time of loading the thicker glasses. So reduce the temperature 680, 690 from 720 thin glass like this. So glass is already tempered or already heat strengthened glasses. So once it is processed, please ensure that all the processed glass should not be fed again, you should not reheat it again. You should not re-temperate again, or you should not reheat it. Reheated process, you should not do that. Once it's done, it's done, because that's a characteristics of stress has been attained already from the surface of compressive zone. There is no longer to rearrange themselves, so you cannot do any mechanical or strength cannot be increased. So it is not advisable to use already tempered glasses. Should not be fed as once again we should not use for tempering. So which means we should avoid. So never load furnace with already treated glasses. That's the solution. Next, the glass breakage inside the chiller. So why it is breaking? Let's see the reasons. Glass is unable to withstand the cooling. Increase the heating time or furnace temperature. Basically, it has a low cooling. So you have to increase the heating time or furnace this thing. The main aim is to increase the heat, because the glass is not withstand the heat or withstand the cold. So better increase the heat a little bit than the proposed one, so that we'll get it. And edge of the glass is not proper, has a nicks and hairline cracks, which you're not able to understand the hairline cracks, or if any already nicks, for example, during the grinding process, there may be some particle would have been left at the grinding portions, or they'd have a shelf formed there. If they're not flattened enough, the polish is not flat or arising is not flat, if you fed as inside the furnaces, it will start breaking it. So make sure the glass has a properly leveled, properly edged, finished. Heating time is too short or uneven. Having said that, heating time, which is temperature is very less, so either we have to increase the temperature or heating time we have to increase. Check for the furnace type. If only radiation type, change the convective heating. Avoid uneven heating, which means the radiation type, you have to increase more heat. I mean, heating time has to be increased 10 to 20% than the convection type, because the radiation type, where you are feeling the heat because of the electromagnetic waves, there will be a considerable loss of heat loss. So the significant temperature changes, I mean heating uniform take place at the convection type, whereas radiation type you have a greater loss in terms of radiation types. So thereby you need to have a more heating time, up to at least 10 to 20% than the convection system. Quench pressure is too high. Change the nozzle opening, because the rate of opening is much more higher, so that we have to change it. Some nozzle are clogged, a problem of flatness exists. If you're not done properly maintenance or schedule or breakdown maintenance or preventive maintenance, you're not done so far, what happened after a couple of months, all the dust has been accumulated on the orifice of nozzle. So when the glass comes into the quenching portion, those dust, it will not allow further air flowing to quenching session, cooling session. It is a blockage, which is it is a completely useless if you use those kind of air nozzles. So better we have to clean that surfaces, thereby the uniform air flow will be blown through the orifice of nozzles. So check this blocked nozzles. If it is blocked, it can be cleaned, and further blocked, kindly replace it. That's the best solution for this. Figure 62 what is helping to understand this. This is the cupping, this is the concave, this is the convex types of defects which you would have seen that. So what we can do in this, either increase the top temperature, you have to reduce the temperature. Let's see the bottom, let's see the reasons in rectification. Top surfaces of temperature is higher than the bottom surfaces temperature when the glass come to the out of furnaces. Increase the bottom temperature of furnace or decrease the heating balance pressure. Top side quenching power in chiller is lower than the bottom side. Set the furnace temperature properly so that chiller air pressure is adjusted. So that's the rectification we can do. And this is the bistable problem. When the glass is heated up, any one side will be heated up further than the other side. So glass temperature in the middle is lower than the edges. That's the which means the center will have a more, the middle is a more, the edges are very less. Our edges is high, our middle is lower. Rectification: increase the temperature in the middle, changing the temperature profile. Adjust the convection furnace by changing the heating balance. Increase the heating time. So waviness, this is the most common defect for all the tempered glasses. It cannot be avoided. It can be slightly modified, or you can say slightly eliminated with help of convection system with the heating time changes. So reason is the temperature of the glass is too high when it comes out of furnaces. Reduce the temperature and furnace or heating time. Mostly if you reduce the heating time gradually, you'll be able to attain a proper distortion less tempered glass. Roller arrangement is improper is not. If it is not proper roller's distance, and waviness will be obvious. So thereby the equal distance has to be measured. If anything is any problem with align, we have to be carefully has to be settled out. So basically the rectifinish, align the rollers properly. Spots and coating scratches is basically this can happen pre-processing time, like coating scratches either in the form of grinding, in the form of washing brushes and everything. So these are the common defect at the time of pre-processing. So glass is too hot when it comes to furnaces. Reduce the furnaces, which is with respect to spots. These are the solutions which we are talking about. Lumps have accumulated in the roller surfaces, which means in this rollers, you can see that there is a white spots, which is so you see that, which means already the broken pieces of glass particle which is sticked on the rollers, which will causes the white mark spots on the tint back side of the glass. Clean the ceramic rollers. Basically, you have to clean the ceramic roller. Coated side was placed upside down. Never place coated side on the roller faces. So the coater, if you keep it on that, again you'll have a problem. Glass temperature is less. Increase the heating time or increase the quenching pressure. So that way we will not have any spots like what you saw. This is the grayness of the coating. Low-E glasses, basically it will be commonly seen through. So basically the insufficient amount of sulfur dioxide SO2 to be used. So temporarily increase SO2, or better not to use SO2 for the Low-E glass processing. We should not be used for Low-E glass processing for at least 24 hours. So prior to Low-E glass processing, you have to ensure that SO2 should not be used for Low-E glass processing. If you're using it, such a kind of defect may comes. Again, cracks, which you're having said that earlier. So it's a many reason. Let's look at it. The one reason is the glass was too cold when it left in the furnaces, which is not sufficiently heated up. So increase the heating time, or in case any shell edges like pre-processing time, if it is not properly grind enough, that will during the chiller it will breaks. And coating burns is the most important for Low-E glass processing. The coating unable to withstand the heat. So basically we have to reduce the heating time or reduce the top temperature. And coating burns in the edges. This is also commonly used for this also commonly widely has been seen so far in this Low-E glass processing. If they are using kerosene, like sometimes people in the cutting oil, they'll mix with the kerosene in order to liquidate, dilute one. So please not to use any kerosene. So if you use kerosene, this during the cutting machines, so that will seepage. It will be seepage on the coating face that we capture. During, if it is not completely washed away during the washing machine, during tempering, it will create as a defect. And finger marks of the operator present in glass. If a people is not using the proper gloves, that body oils, sweatings, those marks will be imprint on the coated face. So prior tempering, which you will not able to notice. After tempering, obviously whatever your fingerprints would be imprinted on this coated face. Basically it's a coating burn kind of this.